Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains SR Linux equal cost multiple paths for BGP. The equal cost multiple paths ECMP function allows a router to distribute packets destined to a given destination over multiple paths if available, as long as these paths satisfy two conditions. First, the paths must have the same routing cost to the destination. Second, the destination must be learned from the same routing protocol. ECMP can be enabled for static routes as well as dynamic routing protocols. ECMP is enabled for a static route by configuring multiple next hops with the same cost. ECMP is enabled for a dynamic routing protocol, such as OSPF, ISIS, and BGP, by explicitly allowing the routing protocol to select multiple next hops and store them in the route table. The ECMP next hop selection algorithm ensures that all packets belonging to the same flow take the same path. This is required to avoid packet reordering. The algorithm is a hash function that takes as input the source and destination IP addresses, the source and destination ports, and the protocol, either TCP or UDP. These fields are the same for packets belonging to the same flow. A hash seed unique for each router is also used as input to the hash algorithm to randomize the path selection on different routers. For example, a given flow may follow interface 1 on the first router and interface 2 on the second router. By default, the hash seed is generated using the chassis MAC address, but it can be explicitly configured. The leaf and spine topology used in data centers offers multiple paths to reach a given destination. Any spine router can forward traffic from one leaf to another leaf. BGP is the protocol of choice for the underlay routing in data centers. In BGP, destination prefixes are propagated as BGP routes, and a router might have multiple paths to reach a destination. By default, the BGP best path selection algorithm selects only one best path for each route. As a result, only one next hop is used for traffic forwarding in the data plane. Configuring BGP multipath allows BGP to select multiple best paths to a destination, enabling the load balancing of traffic across multiple BGP next hops. Now let's look at an ECMP for BGP use case. A prefix is advertised by leaf 2. The route is propagated to leaf 1 through spine 1 and spine 2. Configure BGP multipath on leaf 1 to load balance traffic across spine 1 and spine 2. Okay, we will focus on the leaf 1 router. First, we will check the hash options that are used as input fields for the hash computation. By default, the hash is based on the 5-tuple, and the hash seed key is generated by the system using the chassis MAC address. Show the route table for the prefix 2.2.2.2. There is one next hop for data forwarding. Show the received BGP route. The route is received from two neighbors. Path 1 is propagated by spine 1. Path 2 is propagated by spine 2. Path 1 is valid, best, and used. Path 2 is valid but is not best nor used. By default, the BGP path selection algorithm selects only one best path for a given route. Let's enable ECMP for BGP IPv4 routes by configuring multipath for the IPv4 address family, and let's set the maximum number of ECMP next hops to 2. Recheck the route table. There are now two next hops for the prefix. Traffic destined for prefix 2.2.2.2 will be hashed, and then load shared between the two next hops. Recheck the BGP route. Both paths are now best and used. ECMP is activated for BGP on leaf 1. That's it for SR Linux equal cost multiple paths for BGP. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.